This article was lengthy, but very interesting and connected quite a bit to what we've learned in 580. It discusses the use of diagrams in math, and I just put kind of a couple of quotes here as I'm sort of summarizing, and how the diagrams basically evolved during the Renaissance period. The use of perspective to give a sense of depth was specifically discussed. A lot of discussion about how the visual art underwent such a rapid change and how the historical and cultural context in which the diagrams were created sort of evolved. Or traditionally, math was relied upon words, not pictures, to convey ideas. And an example that I'll talk about briefly in a minute is Euclid's proof about the isosceles triangle. Illustrations that were made were copied from manuscripts by people who most likely didn't understand the importance of the diagram they were drawing, which accounted for maybe this idea that the article reference called conservatism, which I didn't really know what that was. And from the article, my understanding is that it's really showing things in their true shape, not as they appear. And that's something that really is a quote from J.V. Fields. So you see this conservatism in the style of diagrams during this period. Field argues that these diagrams played a very big role in how mathematical knowledge was developed. And the article gives a lot of insight into how art and math really kind of intersected during this time in history. It was really a long article, so the summary was a little long as well. How does the article connect to Math 580? I thought there were several notable connections. The first would be Euclid. The whole first portion of the article talks about really the ancient times and the Greeks and the style of Euclid's elements. So his deductive style of reasoning would have led to an absence of general diagrams. And so I have here book 1, proposition 5. I can remember this being hard, some of those math problems where there wasn't a picture going with his proposition and having to try to draw some of that out from his wording. His propositions a lot of times sound like instructions for how to draw what he's describing. So we had a lot of discussion of Euclid in our class. So this article really kind of connected there. This is obviously a later picture. And J.V. Field says, hey, the drawings are basically left to the reader. We also, let me see, the scribes, we connected that in class. We talked about scribes in the very, very early portion. There was a lot of discussion here about the repeated copying from one manuscript to another mentioned in our class, plus in this article as well. A lot of the diagrams came later, and texts that did survive, we see that the diagrams were put in second to that, and so we see that that was done second to the wording. The quality of the illustrations a lot of times didn't match the writing because you oftentimes had people that were drawing the pictures that didn't really understand what the writing meant. There were other connections here. The article talks a lot about perspective, and so you see changes in the art during that time. And here's Da Vinci, of course, who's got, beautiful images here of perspective. There's another huge portion of that article mentioning the change in those kinds of pictures. The connection for me really came because as someone who teaches physics and astronomy, this idea of perspective is really, really important. And I find that students often struggle with that. They have a lack of spatial awareness, and especially in a course like astronomy, most everything they see in a book is two-dimensional, and they have to try to figure that out and then make a translation over to that same thing that's in 2D in a sort of a three-dimensional representation, and that can be very difficult. I also had not given much thought to the role of pictures and kind of like how that played a role in early math, or the lack of pictures. So I really, learned that the diagrams we have now play a completely different role than they did perhaps earlier on. I have a little video here. I'm not sure it will play, but as I fast forward through, you can see that this is the three-dimensional picture right here of what that two-dimensional picture is. So it was very, very informative.